Hello guys, in this video we will be seeing about mossbauer spectroscopy. The introduction part alone will be discussed. Mossbauer spectroscopy is actually based on the absorption of the gamma rays. In this case, both the absorber and the emitter of the gamma rays will be of the same kind of nucleus. Absorber is a one which is under study. It's a material of the element, and the emitter will be a pure element of the same kind. This effect was first observed by mossbauer in 1958. He was awarded Nobel Prize for this work also. So mossbauer spectroscopy emitter and absorber both are same nucleus only, but absorber it is under study, so that may be a material made up of that element. But emitter உங்களுக்கு pure element இருக்கணும் சரியா. So here shown the two picture. One is for emitter. That is, emitter is coming down from the excited state to the ground state by emitting the gamma rays, and the gamma rays are absorbed by the absorber, and absorber goes from the ground state to the excited state, and the transmitted rays are studied, detected by detector, and the recorder records a peak as shown here, that is characteristic to the substance under study. Mossbauer spectroscopy is based on recoil effect, isomer shift, and Doppler effect. We will be seeing one by one. So what is recoil effect? Recoil effect means whenever a high energy particle is coming out from here, from any body, the body is kicked back. Okay, so for example, when we shoot with a gun, the bullets are coming out with a high energy and the gun is kicked back. So that effect is known as recoil effect, and some energy is taken up for this recoil effect. The recoil energy is equal to E gamma square divided by 2mc square, where E gamma is the energy of the gamma radiation, and m is the mass of the emitter, and c is the velocity of the light. So it is very obvious that if mass of the emitter is greater and the recoil effect or the energy of the recoil will be lesser, so that will be suitable for the mossbauer effect. For mossbauer effect, the recoil energy should be less. So only the solid substances are studied where the recoil effect is less, and not the liquid and the gaseous state not studied. So to understand more, look at here the two diagrams given. One shows the transition that is occurring in the emitter, and the other one shows the transition that is occurring in the absorber. In the emitter, the energy of the gamma rays is less than the transition energy. So gamma rays energy is equal to transition energy minus recoil energy. And in the case of the absorber, the energy of the gamma rays that is absorbed is greater than the transition energy. So energy of the gamma rays is equal to transition energy plus recoil energy. So let us see now about the isomer shift. So here the transitions for the source and absorber is shown here. See, actually the absorber and the source may be a same element, but absorber is in different environment. Here the element is in a material. So naturally the two transition will not match. So slightly the energy levels are shifted to a greater level. So that we call it as a isomer shift. It is the energy or frequency shift in the atomic spectra which occurs when one replaces one nuclear isomer by another. So there is a shift in the energy. The energy level is greater for the absorber, but only when the energy levels difference in energy level matches for the source as well as for the absorber, the resonance occurs and the mossbauer peak will be obtained. Okay, so in order to match the energy difference between the energy levels for the source and absorber, Doppler effect is used. The ரெண்டு energies இருக்குங்க, energy difference. So we'll compare it with the movement of the train. The train when it is moving towards us, the sound will keep on increasing, and the train when it is moving away from us, the sound will keep on fade away. So that is actually the Doppler effect. Change in frequency, energy or wavelength of wave for an absorber moving relative to the source or vice versa is known as the Doppler effect. So this effect can be utilized here, and we can match the uh, energy difference between the energy levels for the absorber and the emitter by moving the source towards the emitter. Sometimes the emitter is also moved towards the source to do this. Okay, so Doppler effect is utilized here. It is just a movement only, moving the source towards the emitter. Now, principle of the mass pair spectroscopy, it involves recoilless emission. The emission should have very less recoil effect. So, only it is studied for solid, not for the liquid and gases where the recoil effect will be more. And it involves actually absorption of gamma rays. Atoms in source emitting gamma rays must be of same kind. Okay, both emitter and the absorber should be of the same kind. So look at this. Here the elements that is given in the red color are all mass Baer effective, and black shaded are mostly studied. So these are all studied, and other elements are yet to be studied, frequently studied or given in the black shaded portion. And why iron is most studied? Iron is most studied here because it is a very suitable one. Most frequently studied element is iron. Its source is cobalt 57, whose half-life period is 270, and it decays to iron 57. So since its half-life period is 270 days actually, so it's a stable precursor. The formed iron 57 will decay in two ways. 9% of it will decay straight away to the ground state by emitting 136 kilo electron volt of energy, and 91% of it decays to another excited state with the emission of 121.91 kilo electron volt energy. The lower excited state is having a lifetime of 99.3 ns, which is more stable. This decays to ground state with the emission of 14.41 kilo electron volt. This transition satisfies all the conditions of this transition satisfy all the conditions of mass pair spectra, so it is mostly studied. Other elements that are studied are tin, antimony, tellurium, iodine, xenon, and gold. Thank you guys. I will continue about mass pair spectroscopy in next video. Thank you so much.